Today we're going to review rational and irrational numbers. There are some important state test questions that you'll see with rational and irrational numbers. If you remember what they are, that's why we're doing this review. Those questions should be fairly simple for you to do. So let's go ahead and review these. There's a few vocab words we need to talk about to remember first. Integer, rational number, and irrational number. So integer. The reason you need to know what an integer is because there will be times where they ask you, they'll say this variable represents an integer. So you need to know what an integer is. An integer is just a number with no decimal. So an example, -12, 0, 43. Any number that does not have a decimal along with it, then that is an integer, or an integer. Rational number, it can be written as a fraction. So it can be written as a fraction, that's the first thing. When you see it in decimal form, this is the important part also, because this seems to pop up more often. When it's in decimal form, it is either terminating, meaning it comes to an end, so like whenever you're writing it out, it has its ending point, or it has a repeating pattern. So it has a pattern that continues to repeat the whole time. That is also rational. Examples of that, 4.23. It comes to an end, that means it terminates, it stops. So 4.23 is a rational number. Or 4.181818 and so on. Like it keeps going on forever as 18. If that's the case, then that is also rational because it has a repeating pattern of 18 every time. So both of those are examples of rational numbers. Irrational number cannot be written as a fraction. Okay, so it cannot be written in fraction form, and when it's in decimal form, it does not terminate, meaning it does not come to an end, and it does not repeat. So it does not terminate or repeat. It doesn't do either of those. Its decimal goes on forever, and it has a bunch of random numbers that does not have a pattern with it. So examples of that would be pi or the square root of 8. And like if you plug in the square root of 8 in your calculator, like if you plug in pi, so let's just plug in both of them. When you click the pi button, it's 3.14159.26554. And it goes on, it keeps going on. That doesn't have a pattern, and it doesn't stop, so it's irrational. Also, let's do square root of 8. 2.8284272125. That does not have that keeps going on, and it does not have a pattern either. So that is also irrational. So very important to understand the difference between rational and irrational numbers because you will be asked the difference between the two. So let's go ahead and look at examples and tell whether the square root. So this says, tell whether the square root of the following integers result in a rational or irrational number. So all you're doing here is you're taking your calculator and you're going to take the square root of each of these numbers. If you took the practice test, you probably saw a question just like this. There's a question on a past state test that is just like this. It gives you a bunch of integers and it says the square root of the following, which ones are rational, which ones not. So, for example, let's start with 13. I take the square root, 3.6055551275. That does not have a pattern, it doesn't stop, so that would be considered irrational. Does not terminate, does not repeat, that is irrational. 25, I plug in 25. Its square root is 5. That stops, it's a terminating number, so that is a rational number. Anytime it's a whole number, that is a rational number. 46, square root, 6.7823299883. Again, keeps going on, doesn't have a pattern, that is irrational. 49, the square root is 7. So, the square root 7, that is rational. 88, its square root, 9.380895152. It keeps going on. Okay, so square root of 88 would also be irrational. And lastly, 121, its square root is 11. So there you see that it has a whole number, so it would be rational. So the trick that I would look at for these is basically, for square roots of numbers, if it doesn't come out to an exact number, it's most likely going to be irrational. So like 25, 49, and 121 all came out to be actual whole numbers. If it comes out to be a long decimal, that's probably an irrational number. Okay? So that's how to make sure you can tell the difference between the two. Because like I said, that will be asked of you on the state test. Alright, let's look at another example that you might see. So first, it tells you P is an integer. So if it tells you P is an integer, that means it is a whole number. It doesn't have a decimal. So P is not a decimal. It says the square root of P is between 6 and 7. What is a possible value of P? So if it's a possible value, that means there's more than one answer you could have here. So the best way to start this, if they give you the square, they say the square root of a certain number or a variable is between two numbers. The way to start that would be, I would take the bottom range and I'm just going to square it. Take the power of 2 of it. The reason you're doing that is if I take this 6 to the power of 2, remember, power of 2 is the opposite of square root. So, the 6 to the power of 2 is 36. And I can take the top range, 7. 7 to the power of 2 is 49. So if I need the square root of an integer to be between these two, I just have to pick an integer between these two numbers. For example, let's plug in 37. Its square root, 6.08276253. So the first part of it, 6.08. That is between 6 and 7. Let's pick another number between here. 45. Its square root, 6.708, and so on. So again, that's between 6 and 7. So if you're trying to find just the square root of, like, between two certain numbers, all you have to do is take the power of 2 of each of the range numbers and then pick numbers between them. Remember, it's an integer, so you can't pick like 37.5. It has to be a whole number without a decimal. So we could have picked any of those, but let's just say 37. But you could have picked 37, 38, 39, anything all the way up to 48. So that is how you're working on that one. Okay, so I want you to try the next one. Let me make sure. Yeah. All right, I want you to try the next one on your own. Tell me, see if you can get an answer for it. Okay, so after you've hopefully tried it, pause the video, let's look at what we have. It says the square root of P is between 11.2 and 11.3. What's the possible value of P? So again, this has a smaller range, but I'm still going to do the same thing. If it just gives me the square root of P, I'm going to take each number and square it and see what I get. So 11.2 to the second power is 125.44. 11.3 to the second power is 127.69. So then I have to ask myself, what integers is between those two numbers? This one, there's only two choices you can have. So in between these two numbers, the two integers you could have would be 126 or 127. Those would both fall between these two numbers. So those would both be possible values for this answer. So you could pick either of them. But that's the best and easiest way to come up with numbers that would be between that range. So you take the bottom of the range, the top of the range, and square them, and then find out what integers would be between them. Because then, let's plug it in. 126, the square root. 11.224. That's between those two numbers. The next one, 11.3 squared. Square root. 11 point, what? Sorry, I'm all messed up. So we did 126, now we're doing 127. So 127 square root. 11.269. So again, that's between 11.2 and 11.3. So that is the easiest way to find the number or an integer that would be between those two when you take the square root of them. All right, let's look at another type of problem they might give you. It says the following has a value between 5.6 and 5.7, the following expression, where x is an integer. So again, x has to be a whole number. It wants to know what is the value of x. So we're taking the square root of a number and subtracting off 3.5. And we want our final answer to be between 5.6 and 5.7. So I'll be honest, the best way to do this would be like guess and check it numbers. So I'm going to pick out different integers. So let's start with the integer of 20. So say I plug in 20, take its square root, and then I'm going to subtract off 3.5. So the square root of 20, 4.472135,955. And then I'm going to do minus 3.15, and I get 1.322 and more numbers. So that's obviously not even close to being between 5.6 and 5.7. So I'm going to need a lot bigger number. So let's try 100. So if I plug in 100, square root of 100 is 10. Then I subtract 3.15, and that is 6.85. So we're getting closer. That one's too high now. So we need it to be between 5.6 and 5.7. So let's go down a little bit. Let's go down to 80. Square root of 80. 8.94427,191 minus 3.15, and I get 5.794, so on. So we're getting really, really close. This is just a little larger than that. So if you get this close, you could really just keep going down by 1, because you know you need a smaller one, but since we're so close, let's just go down by 1. Let's go down to 79. 79, square root, 8.888194, and so on, minus 3.15, 5.738, and so on. So even closer, okay, so we might be almost there. So let's do 78. Square root of 78, 8.83176, and so on, minus 3.15, 5.68, and so on. So finally we found the number that is between 5.6 and 5.7. So our answer is x equals 78, because that's the number or the integer that would be between, or that's an integer that would be, when plugged in, gives us an answer here that would work. Okay, so that would be your answer, x equals 78. So that's just some guess and check, but understanding what you're looking for is the most important part. So let's look at one more. It says the following expression has a value between 25.5 and 25.6 where x is an integer. So we have the square root of x, square root of x plus x, and it wants to know what is the value of x. So, again, we're just going to start with, so we know, you can use some thinking on it. We know we're going to be adding on x. So we obviously don't want to pick a number like larger than like 25, because if we're adding on 25, or adding it on, it's obviously going to make it larger than this. So we need to pick a number less than 25. So let's start with like 20. Okay, so say I have square root of 20 plus 20. So I need to plug in the square root of 20, which is 4.472 and so on. Add 20 to that, I get 24.47 and so on. So it's close, but not quite. So we need to go up a little bit. Let's go up 1 to 21. So I plug in 21 in both spots. Square root of 21, 4.5825 and so on. Add 21, and I get 25.582 and so on. So, there we go. There's my answer, because that value right here falls between 25.5 and 25.6. So, my answer would be x equals 21. So all three types of examples we went through are examples that I've seen on the state test before. that have been released for the teachers to see. So that's a very big advantage. If you can do those, that should give you a good idea of what you need to be doing or what you might see on the state test. So hopefully that made sense. Like I said, on the stream, you're going to have a worksheet on this. So make sure you watch this video to give you, and you can go back and watch it again if you get confused, to give you an idea of what's going on. Thanks.